Hello students, today we are again back with one more video of resistors. So in the last video I was teaching you about the resistors which are arranged in series, and we had also got the resistors value, that is nothing but the Rs is equal to R1 plus R2 plus R3. So in today's video I am going to tell you about how the arrangement of resistors are in parallel. So here what is meant by parallel is nothing but the resistors are arranged one below the other. The resistors are arranged in one below the other. So when you are arranging the resistors one below the other, that time what happens is the current which is flowing, that is being divided. The current which is being flowing, that is being divided. The individual current I is being divided into three parts, that is I1, I2 and I3 for three different resistors. But the voltage which is flowing, that is the potential difference across the ends of the conductor which is flowing, that will be constant. So that is the main difference between the resistors which are arranged in parallel and the resistors which are arranged in series. Okay, so now here I can tell. So here from the above circuit we can clearly see that current flowing across the ends of the conductor is varying, that is the current is being divided, that is nothing but I1, I2 and I3, and the potential difference is same, that is nothing but V. So if we write the potential difference, so if we take the equivalent resistance, so complete circuit if we complete it as equivalent resistance, that time what we can do it as, that time we can make it as R is equal to, that time we can write it as I is equal to I1 plus I2 plus I3. Okay, so when we get this as sum of the currents, that is I is equal to I1 plus I2 plus I3, we can apply the Ohms law, where Ohms law is nothing but potential difference across the ends of the conductor is directly proportional to the current flowing through it, that is nothing but I, and this is the resistance. Okay, now we want the current. So when we cross multiply the Ohms law, that is V is equal to I into R, we will get it as I is equal to V by Rp, where Rp is nothing but resistors which are arranged in parallel. This is the equivalent resistors. Okay, so here we can write the individual resistors. Here if we write the current flowing through the individual resistors, what it will be, I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Okay, so that we can take the equations as equation 2, equation 3 and equation 4. So now we want the equivalent resistance. We want the value of equivalent resistance. So when we want the value of equivalent resistance, we will substitute the equations of 2, 3 and 4 in the equation 1, that is nothing but I is equal to I1 plus I2 plus I3. So when we substitute the equations 2, 3 and 4 in the equation 1, we will get it as V by Rp is equal to V by R1 plus V by R2 plus V by R3. Okay, that is the equivalent resistors. Now we can see here current is constant. Here potential difference is constant. So when we take potential difference as common factor, we will get it as 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equivalent resistors which are arranged in parallel, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so now we can conclude in the statement that reciprocal of the equivalent resistors, that is nothing but 1 by Rp of a group of resistors joined in a parallel is equal to the sum of reciprocals of the individual resistance. That is, the complete circuit's complete parallel arrangement is in the form of reciprocals. that is arranged in the form of reciprocal. So for that reason they have given it as reciprocal of the equivalent resistance of a group of resistors. These are the group of resistors joined in parallel, that is they are joined one below the other. That is nothing but equal to the sum of the reciprocals of the individual resistance. So this is the resistance of, this is the equivalent resistor, and these are the individual resistors. R1, R2 and R3 are the individual resistors. So here basically when we are talking about the arrangement of the resistors, they are in two ways. One is the parallel arrangement and in the series arrangement. So by this we will conclude our resistor topic, that is how is the resistance arranged and how what is the constant in which type of arrangement. In my next video I will be telling you about which is the more suitable way of arrangement of the resistors. That is a parallel arrangement is suitable way for conducting the resistors, or a series way. Hope you all have liked the videos and understood the videos. Thank you.